Hello, my name is Luis Fuentes-Montero, but if you meet me in person, just call me Luiso, my nickname. And now I would like to talk to you about Dial's user interface version 2, which will be released very soon. Before talking about dui, I should say what is Dials. Dials is a software project to integrate data from diffraction images. The project started more than 10 years ago and it was funded by Biostruct X and now Welcome Trust. It aims to process data for modern diffraction experiment with have plenty of images, a lot of images, and uses, for example, parallelization with modern computers. It's an open source software, which means you can see the code, you can contribute, you can study the code, and it's supposed to encourage collaboration between several institutions. Dials should be seen as a toolbox more than a single program or a black box. Dials is several tools that are connected one to the next tool. For example, you start spot finding, then indexing, and so on. It's also a toolbox from the point of view of how programmers can use it. You can call Dials tools from your source code from your program. If you are a user of Dials, these are the commands that you most frequently will use. These are the most important, but there are more commands for dials. There are about 60 dials commands, some of them for processing and some of them for visualization or debugging. This way, with command lines, typing one command, expecting the output and reading and using the output for the next command is the way most expert people use dials. Command line is not the only way to use dials. As I already mentioned, there is from a code, a way to use dials. There is dui and there is CA2. In CA2 is the highest level, the way you just type CA2 space directory and then it runs everything for you, all the commands and process for you. And there is dui. That's what we are going to talk about today. It's a graphical user interface where you have plenty of control, almost as much control as the command line tools, but in a graphical, nice way with the mouse clicking here and clicking there. That's what we are going to talk about now. So, what is dui? The acronym, by coincidence, is drive under influence, like drinking and driving, which is illegal. But no, we are not encouraging that behavior here. This is completely different. This is Dial's user interface, a graphical interface for dials. And in this talk, we are going to talk about version 2. Let's start with some features that might be familiar to you from version 1, like the control graph. This is pretty much the heart of dui. This is a multi-branch or multi-node control graph which grows whenever the user runs a new command. This is capable to grow, fork, merge. It lets the user to navigate, to retry, to merge the path while it's processing the data. Then, at the right-hand side of the GUI, there are several visualization tools which update with the growth or the change of the control graph. In the first tab of our visualization tools, we have the image viewer. This image viewer is tunable, the contrast, the color palette is tunable, and it behaves very similar to Google Maps. It updates with the processing steps. For our second tab, we have the log view. This is what we will be seeing if we were running dials from command line. It updates in real time the text output coming out of the dials command. It's very useful for seeing errors, for seeing. This is the way the expert people do. They look at the text coming out of the command line. And it's the fastest way to navigate between nodes in dui. Very important. In our third tab, we have the report view. dui, whenever it finishes running a dials command, it automatically runs dials.report, which generates an HTML page with graphics and numbers that helps you analyze, helps you see the results in a different way. Sometimes it helps you, it complements the numbers that you see in the log view. And in the last tab of the visualization area, we have the reciprocal lattice viewer. This launches a dials command. If you click this big button, it opens the reciprocal lattice viewer. This viewer is a 3D animated visualization of our reflections converted from the images to reciprocal space. This is quite useful when you want to find defects or misadjustment in the instrument or a wrong unit cell. It's quite useful in tuning the geometry of your experiment or of your cell. Now I will start talking about new features you will only find in dui version 2, which will be released pretty soon. Starting with multitasking. Version 2 of dui, when you run a command, it does not freeze the GUI. It lets you run from another branch another command, assuming your processor and your computer has enough power to do that. Another new feature of dui is the capability to combine several processing paths by running dials.combine experiments. Sometimes you have several scans of the same image and you process them separately and then you combine them. For example, here we have 4 branches that represent 4 scans from the same sample that we select them with the mouse pointer and then we combine these 4 branches into this single branch. From this single one, we continue as one branch. Now, I would like to talk about tactics, about how I would like to recommend you how to use dui for processing data. In general, integration takes time, either from the commands processing data and the way dui updates data to you. So you need to be patient. But being patient does not mean you should be shy. You should try. You are encouraged to try different ways to process, try again, fix something that didn't go well, stuff like that. For example, here I deliberately changed one parameter in the spot finding algorithm and dials crashed. The gain should not be 0. So we can fork from here and try again. But with this new fork, I didn't change anything in the parameters. I let it run with the default parameters and it finished spot finding without any problem. We should continue from this correctly finished branch. In the next step, indexing, I'm leaving it with the default parameters. If we see the advanced tab, we see that max lattices is equal to 1. With this default parameter, we see now in the right-hand side the unindexed reflections. There are more unindexed reflections than indexed reflections. Maybe there is something wrong here. Maybe we have another lattice. Let's try with more than one lattice. If we put 5 in the max lattice parameter, it will try to find as many as 5 lattices. And we can see that there are significantly less unindexed reflection, less than 5% compared to the indexed reflection. In this case, we only find 2 lattices. That's okay. We can continue from here. The next step will be refine, starting from the indexed step that gave us more indexed reflections. Now, I would like to go back to features of the new dui. This is something we are testing. This is something that is not yet supported, but will come eventually. This is how to run dui remotely. What I mean with running dui remotely. We aim to deliver in the long term a version of dui that will behave very similar to CCP4 cloud. In one place, you have a very powerful server, and you do all the processing there in this big server. But you control it from a remote place with a very, very cheap computer or a cell phone, maybe. What we achieved so far, I installed it in a server at the north of Mexico, where I did my PhD. I installed dials. I copied experimental images there, and the server side of the dui app. And from the another side of the Atlantic Ocean, in Wiltshire, UK, from my home, I run in a very underpowered laptop in a Chromebook. I installed the client side of the app. I do not need experimental images, and I only need the dials if I need to see the reciprocal lattice viewer, which eventually we will remove that too. We might run it eventually without installing nothing from dials. And so far it succeeded. I processed entirely the integration process. The way these two sides of dui, the client and the server, talk to each other is by HTTP requests. The same way a web browser works, the way they ask the server to show you a new web page. This is, as I said, not supported, actually not even finished yet. But if you want to try what we have already working, you should get in touch. Now, talking about getting in touch. Now is when I would like you to take your cell phone and take a picture of this slide. Here we have the web page where you can report issues and my work email. I would like you to report issues on give any feedback about how dui runs in a traditional way as a local app. The remote mode is not finished yet. You can still try if you want. I will leave the top side of this slide while I do the acknowledgements. Starting with dials, dui is pretty much useless without dials. And dials is a big project developed by a lot of people. Here we see all the people that work on the east side, let's say Diamond and CCP4. And dials relies heavily on CCTVX developed by the people at Berkeley. If I'm forgetting somebody here, I apologize beforehand. There is a lot of people who work in this project. And as I mentioned, Diamond Light Source and Berkeley Synchrotron is where most of the development is done. But I would like to highlight that this is an open source project. You can study the code and you can contribute. Once again, get in touch with the dials people. You can always contribute or study the code. Now, particularly in the development of dui, there is a lot to thank to the people at CCP4 in general, the core team at Research Complex at Harvard, very helpful people. They have been very helpful teaching me how to do some programming, some stuff. At the Cambridge University is where the people who did iMorphing or Morphing, we are still learning from them when we do develop dials. And I'm learning still from them when I from iMorphin when I developed dui. There's a lot that I owe to these people. In York, the University of York, they have been very, very helpful testing dui. Whenever I bring something new or they have a workshop, they let me test dui there. They break it, smash it, and give good feedback. In Newcastle, that's where for first time somebody did a GUI for dials. Long before dui existed, there was a dui developed there by people in Newcastle. And finally, the funding for developing dui is coming half from CCP4, half from Diamond. Once again, thank you.